works for you. But we are now starting chapter 2. So the first notes that are not on the note packet, they're on the old notes. The first notes want to know if these things are polynomial functions. So we need to look at this list of stuff and talk about what are polynomials and what are not. Okay, now, I am going to tell you right from the beginning that A is a polynomial function. This is called a quadratic function. Quadratic means its degree is 2. It's a squared, an x squared. So this is a variation of the parabola, x squared, our BFF. It is a polynomial function. I am going to tell you that this one is not. Can anybody look at these two problems? This one is, this one's not. What is wrong with this one? Logan?
It doesn't have a whole number at the end.
That's okay. It actually can, you can live without it. It has a negative exponent. You are not allowed to have negative exponents. So this is not, well, I'll just say it has a negative exponent. You are not allowed to have negative exponents. So this one is not a polynomial function because it has a negative exponent. Now, you remember from your algebra and from what we did earlier in the year, what do we do when we run into negative exponents? What do we have to do with those?
Make it positive.
And how do we make it positive? No? Well, sort of. We move it to the bottom of the fraction, right? So this, if I were going to redo this, it would be 3 over x squared, because the x squared has to go to the denominator. That's what happened to this one, right? It has an x in the denominator. It is not a polynomial because you cannot have an x in the denominator. Negative exponents give you x's in the denominator. Those are not legal, either one of those things. So if you have an x in the denominator or a negative exponent, you are not going to be a polynomial function. Okay, you're making a list. You can't have a negative exponent. You can't have an x in the denominator. And when I say a negative exponent, I mean on the x. You can't have a negative exponent on the x. You can't have an x in the denominator. Okay? Now, this one's a problem. What do you think's wrong with this one? A fractional exponent. You cannot have fractional exponents. If you have a fractional exponent, that is why you are not a polynomial. So the question, which I wrote on the board yesterday, but I didn't write down here again, is it a polynomial function? And the answer to this one right here that I'm pointing at is no. And the reason is because x has a fractional exponent. Now, does anybody remember what fractional exponents mean? Earlier this year, we had things like 27 to the 2/3. What does that mean, Patrick?
I don't remember which order it goes in, but I know you should use one of the numbers as an exponent and the other to square root it.
It's a radical. Fractional exponents are radicals. The denominator tells you which radical, and the numerator tells you the power. But anytime you see a fractional exponent, it means you have a radical. So take a look at this one. Does this one have a fractional exponent? Yeah.
Yes.
What does a square root mean? 1/2 power. You cannot have x under a radical, because x under a radical is the same thing as having a fractional exponent. You cannot be a polynomial function if you have a negative exponent, a fractional exponent, an x in the denominator, or an x under the radical. Those are the things that keep you from being a polynomial. Let me say them one more time. You cannot have a fractional exponent or a negative exponent on your x. Okay? You cannot have x under the radical, and you cannot have x in the denominator. So those are your rules, all right? So when you look at a problem and it says, is it a polynomial, you ask yourself, okay, what of those do I have or not have? So let's go back and look at the ones we haven't talked about. We already said that one was okay. Take a look at this one. Does it violate any of our rules? No. This is called a constant function. It is a polynomial function whose degree is 0. It is a constant function. What about this one? Does it violate any of our rules? No. It's a polynomial function. Its degree is 3. We would call it a cubic polynomial. It's a cubic polynomial. X cubed. What about this one? Does it violate any of our rules? No, it's a tricky one, because sometimes you'll see the radical and you'll say, wait a minute, that's not polynomial. But what's the rule about the radical? X can't be under it. You can have a root 5, you can have a 5 under it, but you can't have an x under it. Okay? So that takes care of it. So one more time before I erase this and we move on, because this is going to be a test question, but we're really not going to spend much more time on it until we start reviewing. What keeps me from being a polynomial function? Negative exponent on the x.
X in the denominator.
X in the denominator.
Fractional exponent.
Fractional exponent on the x. X under a radical. That stops me from being a polynomial function. All right, everybody got that in your notes? Okay, so then the next one, the directions are on the page that you don't have. Says write the equation of the linear function. So we're going to write a linear function. Now wait a minute. What do you think that means, linear function? It's a fancy way of saying what? Line. I'm going to write the equation of the line. And what I am given is f of 2 is 3 and f of 1 is 5. Now again, this is not new to you. It is written in a new way, but it is not new to you. When we do function notation, don't we say something like y equals f of x? See this right here? The thing that's in the parentheses there? That is your x. So when I come over here and look at this, this is actually an ordered pair, and the x is 2. Whatever you're f ofing, f of x, that is x. So for this one, the x coordinate is 1. Now, by process of elimination, once you figured out that that guy is the x, then this one has to be the 1. So you have been given 2 points, and you are going to write the equation of the line containing those 2 points. Now you've already done that this year, you did it last year, you did it the year before, and the year before, and probably the year before all that. How do we write the equation of a line? That's what we're doing. How are we doing it? What are we doing? We need the slope. So step 1, 5 minus 3 over 1 minus 2. I am not answering any questions about that. You need to know that to find slope, It's y minus y over x minus x. So the slope of this line is -2. Now what? That is not the answer. I am not done. We call it point slope. So now I pick one of my points. It doesn't matter. I'll just pick that one. I can pick either one. Doesn't make any difference. And that's my x and that's my y. And my point slope form says y minus y. So y minus 3 equals m times x minus x. That's your point slope form. And again, we've done all this. You've done this since you were freshmen. Before that, probably. Y minus your y coordinate equals m times x minus your x coordinate. So y minus 3 equals -2x plus 4. Y equals -2x plus 7. Now, here comes the tricky part. The directions, which you don't have, I wrote them yesterday, but I haven't written them up there. The directions said, or maybe I did, write the linear function. So instead of writing y equals -2x plus 7, we're going to say f of x equals -2x plus 7. That's our linear function, which is exactly the same as a line. We just use function notation. Now, the actual note sheet that you have gives you one more example of that. It says do the same thing if f of 3 is 6 and f of -4 is -1. So the directions say write the equation of the linear function where f of 3 is 6 and f of -4 is -1. Okay? This is actually on your new notes now. This is the first problem at the very top. Okay? So here we go. Everybody should have it. Shiloh, are you okay? Or are you some kind of nervous? We're on our notes now. We're on our notes, actual new notes. So, what's the first thing maybe you want to do is remind yourself these are 2 points. What are the 2 points again? 3, 6, -4, -1. This is x. In the parentheses, f of x. That's x. So here we go. Slope will be -1 minus 6, -4 minus 3. Y minus y, x minus x. What's that work out to be?
1.
Wow, that's nice. -7 over -7. 1. Slope is 1. Now pick a point. I think I'll use this one. It doesn't make any difference. Use whichever one you want. And to write your equation, you're going to say y minus the y coordinate equals m, which is 1, times x minus the x coordinate. So y minus 6 equals x minus 3.
Add 6 over.
Add the 6 over, x plus 3. And then to put the icing on the cake, we'll follow the directions, write the linear function. So instead of y, we'll use f of x. So f of x equals x plus 3. So the problem looks different. The directions are a little different, but the process is the same. You're writing the equation of a line.
Can you use slope intercept or no?
Well, the answer's in slope intercept. We don't generally do that from the beginning, but you can. It won't hurt anything. Text.
Yeah.
Why's your hand up?
I'm just like.
Oh, okay. All right. So that takes care of the linear functions. Now we're moving on to the quadratic functions. Those of you who have been coming in for flex know some of this vocabulary already because we have been talking about it in terms of our review work. So first of all, see that squared right there? That means this curve has what shape? Parabola. Anything that's squared is going to have a parabola. DO stands for direction of opening. Our quadratic functions, our parabolas, are either going to open up or down. Now, your BFF, your y equals x squared, that was this parabola, right? That's what you memorized? So it opened up. How did we make it open down? We put a negative out in front of it, and that turned it upside down. So when I look at this parabola, do I see a negative out in front of it? No. So therefore, it must open up. Now, in a while, we're going to look at some harder equations, but this one's really easy if you remember what we learned before. Who remembers what subtracting 3 inside the parentheses does?
It makes it go to the right.
Moves it 3 units to
the right.
right. And what does adding 4 on the
4.
end of it do? Moves it up 4. So instead of this parabola having a vertex at the origin, which is where your basic one is, it has been moved right 3 and up 4. So the new vertex is at 3, 4. And I don't need to do any work. I could, but I don't need to because I remember this goes right 3 and up 4. Now, this is called the axis of symmetry. It is the crease that if you folded the parabola in half, it would be doubled over on itself, the 2 halves. It divides it right in half. And those of you that have been here in flex know what about the axis of symmetry? It's x equals the x coordinate. So x equals 3 is the axis of symmetry of this parabola. So whatever your vertex is, the axis of symmetry will always match the x coordinate of that. That's pretty easy. Let's look at, these go down, so let's look at B. B says y equals 3x plus 1 squared, and we need vertex axis of symmetry and direction of opening. All right, so here we go. Let's take a look at this one. Where do you think this vertex is? How have we moved? This one right here. We went left 1. Did we go up and down at all?
No.
So if we started at the origin and went left 1, our vertex is at the point -1, 0. Which makes our axis of symmetry x equals -1, because the axis of symmetry always matches the x coordinate of the vertex. Now, I kind of gave it away. I opened that one up. Should I have opened it up? Yeah, because the only way it opens down is if you put a negative in front. So that's going to open up. Now the next one is going to open down. Now think about how this moved. Did it go sideways at all? No, because the only way it goes sideways is if you put something in the parentheses with the x. No, right? So I didn't go sideways, but I did go up 4. So where's my vertex? If I start at the origin and go up 4, I'd be at 0, 4. which makes my axis of symmetry x equals 0, because your axis of symmetry matches the x of your vertex. Every time. Oh, this one's easy. All right, here we go. Let's look at this one right here. This is letter D. Tell me about it.
Axis down.
Opens down. Everybody sees that. Oh, that's a no-brainer. We're not going to miss that question, please. If there's a negative in front of it, it's going to open down. If there isn't, it's going to open up. All right, how about a vertex? 1, -2. Are we all in agreement? Because we see in the parentheses, we're going to go right 1 and down 2. What does that make our axis of symmetry? X equals 1. Perfect. This is your BFF. What's the vertex? 0, 0. The origin, which makes your axis x equals 0, always matches this number right here. And it opens up. That's just your standard quadratic squaring function. Last one. Everybody's going to get this right. What's our vertex? 2, 1. Right 2, up 1. Making my axis of symmetry x equals 2. Notice, now I've done, what, 6 of these? And every time I write my axis, it's x equals a number. I don't write just the number. Half point off. Gotta write x equals the number. It's a line. And then which direction of opening for this guy? Boy, are you thinking, man, that's easy stuff. It is. Until we get to this next group. Because what's different about this next group of problems?
You want us to write it in vertex form?
Well, yeah. This, kids, this is called vertex form. Because you can look at it and tell what the vertex is. Right? That's why it's called vertex form. I can see my vertex is at 1, -2. When it's written like this, which is called standard form, ax squared plus bx plus c, you can't look at it and tell what the vertex is. So what this question wants you to do is put it into vertex form. Put it into vertex form, all right? So here's how this works. I have to somehow make this equation look like this. So the first thing I'm going to do is move the 2 to the other side. This 2 right here. So I'm subtracting that 2 over to the other side. So now it's y minus 2 equals this. Now, guess what I'm going to do? I'm going to complete the square so that I will have a quantity squared. So who remembers how to complete the square? We are on problem 4 of our notes, problem A.
Probably to take that
Who remembers how to, no, I could, but that's not how I complete the square. Remember, I take half of this and square it. What's half of 2? 1. Squared is 1. So I am going to add 1 to both sides. So one more time. To complete the square, I take half of the x number, so that would be 1, and I square it, and I get 1. And that's what I add to both sides. Now, I did that because this should factor into a parentheses like that. In fact, it's going to factor into that very parentheses, because isn't this x minus 1 times x minus 1? X minus 1. We did all this earlier in the year. But over on this side, I have y minus 1, because when I add those together, I have y minus 1. Now I'm almost done. To make that equation look like that one, I just have to move my 1 back over. So y equals x minus 1 squared plus 1. Now, put that down. You don't need that on now. We're all done. X minus 1 squared plus 1. Looks like that. So you should be able to tell me my vertex, axis of symmetry, and direction of opening. What's my vertex? 1, 1. What's my axis of symmetry?
X equals 1.
X equals 1.
Opens up.
And which way do I open? And we figured that out. There's 2 ways to figure that out, and we're going to learn both ways. You're going to have a favorite. I have a favorite, and this is not it. But we've got to know this process because it's going to help us with our circles, ellipses, and hyperbolas. There's no way to do those without going through this process. So that's why we have got to practice it.
Where'd you get the plus 1 from, I guess?
Take half of it.
Oh, that?
Yeah.
Half of this squared.
Okay.
All right, let's try another one. Let's work through the process again. We're putting our equation into vertex form. All right, this one's a little tricky. Any idea what step 1 might be? Divide everything by 2. I love it, Sam. But when you say divide everything by 2, you mean everything. So this, 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 and this. So we have y over 2, which is not a big deal. Don't worry about it. He's exactly right. It's fine. Equals x squared minus 4x plus 5. Any idea what the next step might be?
Subtract 5.
Subtract 5. So y over 2 minus 5 equals x squared minus 4x. So far, so good. Now I need a purple number to add to both sides.
2.
No, it won't be 2.
4.
It'll be 4. Because remember, to get this purple number, you take half of this and square it.
So it's 4.
So half of 4 is 2, and 2 squared is 4. So you have got to remember that's a 2-step process. You take half of this and square it. Half of this and square it. Now, this should be your parentheses squared. X minus 2. Remember, these signs always match up. So if that's a minus, that's automatically going to be a minus. So x minus 2 squared. And over here, I have y over 2 minus 1 when I combine those. Now, we're not quite there yet. What do we need to do?
Add it to the left side.
I got to add the 1 back over, so we have y over 2 equals x minus 2 squared plus 1. Can I add this to the other side?
Then times it by 2. Right?
And we times by 2. Now, this is a little bit tricky, so listen carefully. We're going to times by 2. This is how that happens. The 2 goes in the front of the parentheses. It does not impact the parentheses. You multiply the parentheses by 2 and the number by 2. So when you multiply by 2, you multiply the parentheses by 2. and the number by 2. Nothing inside. Don't change the inside. So your vertex is 2, 2. Right 2 up 2. X equals 2 is your axis of symmetry. And up is your direction of opening. Emergency? Hurry up. Oh my Lord, look at this.
You just times it by 3, right?
Oh, I heard somebody say something.
Times it by 3.
Times it by 3. Look at this mess. We do not want to deal with this, so we are going to multiply everything by 3. So I will have 3y, x squared, 4x minus 20. Now take a look at that. Make sure you understand what I did. I did exactly what Logan told me to do. I multiplied everything by 3. When you multiply this by 3, doesn't the denominator go away?
Yeah.
So it's just x squared, 4x minus 20. But the 3 does show up over here. Now if I divided, I'd be right back to where I started. So eventually I'm going to divide, but first I'm going to do some other work. So add the 20. Is there a reason why you do what? Okay? I'm making room for the new number I'm going to add. When you complete the square, you have to add something. So what is the new number I'm going to add?
4.
Half of 4 is 2, and 2 squared is 4. So to get this 4, I take half of this and square it. Half of this and square it. That gives me a 4. So I have 3y plus 24. Now what parentheses is this?
X plus 2.
X plus 2. If you FOIL out x plus 2 times x plus 2 is x squared plus 4x plus 4.
That makes sense. Oh,
Now we're going to subtract 24. And then, Maddie Claire, we're going to divide. Okay? What are we going to divide by? 3. When we divide by 3, it looks really weird to put a parentheses divided by 3. So we normally make it 1/3. So instead of putting the parentheses over 3, instead out in front we just put a 1/3.
We can take both ways.
No, that's the way we write it. And then when I divided, the negative 24 became a negative 8. Because when we do that division, or multiplication, either way, whichever way you're going, you multiply the parentheses itself, or divide the parentheses itself. That's how I got 1/3. And then you divide the number. Don't mess with what's inside. So, where's my vertex? -2, -8? Right? Left 2, down 8? What's my axis of symmetry? X equals -2. Don't be lazy. Don't write -2 because you're going to miss half credit. It's x equals -2. And the reason I'm so picky about that is when we get to parabolas that open sideways, Then you have to stipulate it's y equals negative 2. So we gotta make sure we're used to putting a letter
Do
in
we
there.
need to do all, so we have to do all that for those problems?
Uh-huh.
Make, find the vertex,
Yep.
vertex and everything?
You do if it says find the vertex form. You do. Now I'm gonna show you another way. But first we're doing following the directions. What's my direction of opening here? Oh. How do I know it's up?
And then
Positive 1/3. One more of these, thank the Lord. Multiply, actually Sam, I'd probably multiply by negative 2. Does that make sense to you? So negative 2y will equal what? If I multiply by negative 2. X squared, 6x, I'm multiplying by negative 2 plus 5. You know, I'm ancient, I do this for a living, so I do that in my head, but you might want to write, you know, put a times negative 2 here to remind yourself you're multiplying everything by negative 2. So that's how we got an x squared, these cancel. That's how we got a positive 6 and a positive 5. What's next? Come on, stay with me. Let's go. Minus 5, so negative 2y minus 5.
X plus 6 is equal to x plus 6 squared.
I'm going to add what to both sides? I'm going to add 9. And I'm adding 9
Oh,
because half of 6 is 3, squared is 9, which makes this parentheses x plus 3.
yeah.
And over here, negative 2y plus 4. You're adding a negative 5 and a positive 9. So subtract the 4. Divide by negative 2, but instead of putting it over 2, we're going to say negative 1/2. And that's going to become plus 2. You did it? Congratulations. Give me the vertex, axis of symmetry, and direction of opening.
Negative 3, 2.
Negative 3, positive 2, left 3, up 2. X equals negative 3, down. Perfect. Tomorrow I am going to show you a different way to do that. Or not tomorrow, I guess. Oh my gosh, Monday? You gotta wait till Monday, try not to lose sleep over it. But I'll show you a different way. But I promise that you will at some point have a question that says, complete the square to put in vertex form. Okay? So you need to know this, even though I'm gonna show you a different way. All right, we're not done. We gotta get through this next section. Here we go. This is backwards. So I need you to really pay attention here. This isn't hard. I need you to look at this equation right here that we just finished. And what did you tell me the vertex of this was? Negative 3, positive 2. So I want an equation that looks like that one. Right? And I know the vertex is negative 2, negative 3. So what would that have to look like in the equation if it's -2, -3?
Throw 2 in that blank.
X plus 2
Minus 3.
and minus 3. Does that make sense to you?
Yeah.
That would be the vertex of -2, -3. Good? What do I not know? I know those two numbers are the vertex. What number in this equation do I not know?
12.
That guy right there? I don't know what that is. So I'm going to call it N for a minute. I have to figure that out. That's going to take some math. I'm going to have to figure that. But it's not bad. Because see this point right here?
Yep.
That tells me that if I put a 1 in for the X and a 2 in for the Y, then I ought to be able to figure out what that number is, right? If 1 for X matches up with 2 for Y, then I have this equation.
1/3.
So what's 1 plus 2 squared? So 2 equals 9n minus 3. Everybody got that?
Went up down. 5 9.
1 plus 2 squared is 9. So I have 9 times n. How do I solve that?
Add a 3 over.
Add a 3,
Divide by 9.
divide by 9. So the answer to the question is y equals 5/9 x plus 2 squared minus 3. Now I gave you 2 pieces of information. Which one did you start with?
Vertex.
The vertex, because that's just a plug-in. Then you use the second piece to also plug in for y and x, and that's how we figured out n. Do the same thing on the next one. So we have a vertex at 0, 1, and we contain the point 7, 3. What does the vertex tell me about my equation? Y equals, what's in the parentheses? X minus 0. And then on the end would have to be plus 1. Everybody okay with that? Now the only thing I don't know is what is this coefficient out here in front?
350.
But I can figure it out by putting 7 in for X and 3 in for Y. Now believe it or not, the biggest mistake that's made in these problems is because we write the equation in this order, people put the 7 here and the 3 here. You understand why the 7 has to go here and the 3 has to go here. So 3 equals 49n plus 1.
It's 2 49s.
7 minus 0 is 7, squared is 49. So 2 equals 49n, and n equals 2 49s. So then I write my equation, which would be, go back to this, y equals 2 49s. Now, you can do x minus 0 squared, or you can just do x squared. It's up to you. And then what's on the end? Plus 1. You don't have to put the 0 in ever. One more and we're done. With 3 whole days. Ah! No, I'm not okay. X minus 2 squared minus 1. Can I start like that with a vertex like they gave me? Is that okay? Does that give me a vertex of 2, -1? I don't know what this number is. I'll call it n. But I will figure it out by doing what? negative 5 for y, and 4 for x. So negative 5 equals, okay, what's 4 minus 2? Squared. So 4n minus 1. Add 1. So I got negative 1 this time, a nice number. Then I write my answer. Y equals negative 1, x minus 2 squared minus 1. We're done for the day.
Oh.
Thank